Alright guys, in this video we're going to work questions 3 and 4. You did not have a calculator for these questions, so anyway, yeah, we're going to work through them. So take a look at the first one. It says our function is continuous, -6 to 5. Okay, which should strike you as a little bit weird because my graph only goes to -2. Then it says the figure above shows a portion of the graph consisting of 2 line segments and a quarter of a circle centered at 5, 3. Then it says it's known that 3, 3 minus root 5 is on the graph of f. So I'm going to put f of 3 equals 3 minus root 5. Okay, so this is basically the exact same thing as what they gave you. It's just kind of a different presentation. Okay, so look at part A. Part A says, if the integral from -6 to 5 is 7, find the value of the integral from -6 to -2. Show the work that leads to your answer. Okay, so you had to really kind of think about, if I want the integral, let's do it down here. If I want the integral from -6 to 5 of f of x dx, that is the same as the integral from -6 to -2 plus the integral from -2 to 5 of f of x dx. Now you might be wondering, okay, well how would I know to have broken it up there? Okay, well look at my graph. My graph doesn't start until -2. And they're asking me to find -6 to -2. So that means that this is the part of the integral that I'm having to solve for. Okay, now let's think about, well, I already know -6 to 5, that's 7. So I'm going to do 7 equals -6 to -2 f of x dx plus, and then think about, well, how can I work that out? Well, that's going to be the area of my graph. So from -2 to 5, look at your graph up close. Okay, the first area that I have from -2 to -1 is a triangle, but then if I keep shading from -1 to 0, I have another triangle below that's the exact same size. Those cancel out. Same thing happens again here. I have a half triangle and a half triangle. Those cancel out. Okay, as I keep shading, so I'm going to switch colors here. I'm going to keep shading from 1 all the way to 5. Now, the way that I'm going to have to break this up, we're going to have to get a little creative. So the first shape is not so bad. Okay, you should look at this guy here and see that this is a trapezoid. Okay, my blue shape is a trapezoid. So when I find the area of a trapezoid, remember that it's 1/2 base 1 plus base 2, so that's 1 plus 3. And then my height, which is 1 wide, then I'm going to do half of 1 plus 3 is 4, half of 4 is 2. Okay, so that's the trapezoid part. Okay, the remaining section that's left over down here is a really weird shape, but I want you to remember that up here it says this is a quarter of a circle centered at 5, 3. So if my center is here at 5, 3, okay, think about it, I have a big circle, okay, that I just can't see the rest of right here. Well, then if I want to know this area, I'm going to find the area of this square, and then I'm going to minus out the area of the quarter circle. And so whatever is left over is going to be this remaining orange part on the bottom. So I'm going to do the rectangle, well, really it's a square, minus the quarter circle. Okay. So let's think about the square for a second. This distance is 3, this distance is 3. So that's 9 minus. Then for my quarter circle, it's going to be pi r squared, but my r in this case is 3. Okay, keep in mind that if this is the center, then this is my radius right here. So it'd be pi times 3 squared, but then keep in mind I'm not minusing the whole circle, I'm only minusing 1/4 of it. So if you wanted to reduce that, that would be 9 minus 3 squared is 9 pi fourths. Okay? And then remember that all these other areas canceled out, so that's why I'm really only taking into account the 2 from the trapezoid and the 9 minus 9 pi fourths from the quarter in the semicircle. So I'd have 2 plus 9 minus, 9 pi fourths. Okay? Now, I'm going to do one more step here and say, okay, well then 7 equals the integral from -6 to -2 of f of x dx plus 2 and 9 make 11 minus 9 pi fourths. And so then in order for me to solve for this, I'm basically just going to take this term and subtract it across to the other side. So I'm going to put that the integral from -6 to -2 of f of x dx equals, I have my 7 that's already over there, but then I'm going to have to minus the 11 because it was positive, and then I'm going to have to add the 9 pi fourths because it was negative. If you wanted to, you could combine 7 minus 11 as -4 plus 9 pi fourths, but I probably would not have done that, but either one of those would have worked. Okay? All right, let's go on to part B. Part B was easy, 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 and there was one just like it on your mock exam. So we have the integral from 3 to 5 of 2f prime of x plus 4. Well, then you would take the antiderivative. 2f prime of x, the antiderivative is 2f of x. The antiderivative of 4 is 4x. Then I'm going to plug in 5 and 3. So I would have had 2f of 5 plus 4 times 5. And then on the bottom I would have had 2f of 3, 4 times 3. Now, f of 5, if I look at my graph, f of 5 in the graph is 0. I can see that. Oh, I hope that you could see all the area stuff I was doing up there. F of 5 is 0. And so if this term is 0, that means that the 2 times 0 crosses out. Really, that's just a 20 on top. But then for the bottom, f of 3 is where this annoying 3 minus root 5 is going to come in. Okay? So I would have had 2 times f of 3 is 3 minus root 5. And then I have plus 4 times 3 is plus 12. And then remember that once you do that, you just take those two things and you subtract. So my final answer for part B would have been 20 minus, and then 2, 3 minus root 5, and then plus 12. Now, if you wrote it like that, you did not get the point, because remember, I'm subtracting this whole thing, so you would have had to either group it, or you could have put the negative on the 12 as well. Okay? All right, part C. Function g is given by the integral from -2 to f of x. Okay, so we know that g of x has an integral in it. Then it says find the absolute maximum value of g on the interval from -2 to 5. Justify your answer. Okay, so the first thing I need to look for is a relative minimum. So if g of x is the integral from -2 to x, then I know, this is part C, then I know that g prime of x is the derivative of f of x in an integral, which means that I just take the x, plug it in, so really it's just f of x. Okay, then I'm going to look up at my graph here. Okay, I see that f of x changes sign at -1 and at, it looks like a half, but since I'm looking for a maximum, I'm not going to keep both of these. This one is the max. I don't really care about the 1/2. That's the minimum. So I'm going to put for my part C answer, I have a relative maximum at x equals -1 because f prime of x, g prime of x, which is really f of x, changes from positive to negative. Okay, however, if there is more than one candidate, you have to make a candidate's chart. And in this case, we know that there is more than one candidate because not only did I have a max, but I also had a minimum. So in my chart, I'm going to put -1, that was my relative maximum. I'm going to put the other endpoints of my interval, which were -2 and 5. X, g of x. Remember that we're wanting to see the max value of g, so we need to plug into g. And remember, g had an integral in it. So if I want g of -2, that's going to be the integral from -2 to -2 of f of t dt. Okay, but think about it. If these are both -2's, that's going to be 0. Okay, next one, I want g of negative 1. Well, then that's going to be the integral from negative 2 to negative 1 of my function f of t, and then I'm going to have to do a little bit of area. So let's come back up to our graph from negative 2 to negative 1. Okay, I've accumulated this little triangle here. 1/2, 1 times 1. So it's a total area of 1/2. Now, notice that it's a positive 1/2 because that little triangle was above. Okay, then for my last one, I need g of 5. That's negative 2 to 5. F of t dt. And remember that I already did all the work from this. The answer is right here. Okay, remember, I already did the work from that in part A. I got 11 minus 9 pi fourths. Okay, so then in kind of estimating that value, I would just think about that 9 times pi is about 9 times 3, which is 27. 27 divided by 4 is about 26 divided by 4, which is about 6. So if I had 11 minus 6, that would have come out to be around 5. So if this is 0, this is 1/2, and this is something around the value of 5, then I know that this is my absolute max. So I would put my absolute max is 11 minus 9 pi fourths at x equals 5. But you did have to make a candidates chart there because there was a relative min and a relative max. That means you can't use that argument, oh, it's the only one. Okay? Last part, part D. See if I can squeeze it in here. So part D says to find the limit as x approaches 1 of 10 to the x minus 3f prime of x over f of x minus inverse tan or arctan of x. So remember that for most limits, the first thing that you would do is just try to plug it in. So I plug in my 1 here, I get 10 to the 1 minus 3 times f prime of 1, okay, over, then I have f of 1 minus inverse tan of 1. Okay, we'll think about, okay, 10 to the 1 is just 10 minus f prime of 1 is going to be the slope of the graph at 1. So I'm going to come back up here to my graph of f. At 1, I can see that it's up 2 over 1, up 2 over 1 for that line segment. So the slope of my graph here is 1. Okay, then f of 1 is going to be the y value. So I'm going to come back up to my graph here. Okay, at 1, my y value is also 1. So f of 1 is 1 as well. Then inverse tan of 1, that's pi fourths. Okay, hopefully you know that, but think about at pi fourths, sine and cosine are both root 2 over 2, and so if you divide those, the inverse tan of 1 would give you pi fourths. Okay, and then from there, I'm just going to leave it. Remember that as long as neither part of your fraction comes out to be 0, then that's your answer. Now, you could have done 10 minus 3 and gotten 7 over 1 minus pi fourths. I'm not sure why that might make anyone feel better to subtract it, but it is totally unnecessary. Okay? All right. I'm going to come up here to the top. If you need to see that top part that we did for part A, I'm sorry that I didn't have that zoomed in well when we did it. But we had our trapezoid right here. This is me showing the formula for the trapezoid. And then this is my quarter circle. So I did the square minus the quarter circle, and that's where we got the 9 minus 9 pi fourths. Okay? All right, other one that we're going to do on this video is number 4. Go ahead and turn to number 4, please. Okay, it says a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure. The water drains out through a valve at the bottom. The rate of change of the height with respect to time is given by this model. Okay, so that's a differential equation. Then it says height is measured in feet, t is measured in seconds, and then volume for a cylinder, the formula is given. Okay, part A says find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. So we have a find, given, when for part A. We are asked to find the rate of change of the volume. That's a dV/dt question. Okay, we were given dH/dt. Normally they give you like a value for this, but in this case they gave you an equation instead. Okay, so that's okay. And then it tells you when the height of the water, h, is 4. Okay, so first thing that I'm going to do is look at my volume equation that they gave me. So it's right here, and it says that volume equals pi r squared h. Now I want you to think about that. For a cylinder, regardless of how high this water level is, my radius here is always the same. I was about to say it's always 2. It's always 1. Okay, remember that if the diameter is 2, the radius is always 1. So because it's always 1, I can go ahead and plug that in and say that V is really just pi h, because 1 squared is really 1, and the radius is not a variable, is not changing or a variable. That's why I'm allowed to plug it into the derivative. So if you remember on your homework about that pool problem, okay, kind of the same thing here. So dV/dt is going to be pi, and then the derivative of h is dH/dt. And then I'm going to go back and I'm going to sub in the formula that they gave me, -1/10 root h. Then from there, I know that my h is 4, so I'm going to plug that in here. So dV/dt is going to equal pi -1/10 and then root 4. Root 4 is 2, so that's pi times -2/10, which is the same as -pi/5. Okay, but you would have gotten the point as long as you'd gotten it to there for part A. Okay, part B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. Okay, think about, I want to know if the rate of change is increasing or decreasing. That means that I need to take the derivative again and plug in 3. So, for part B, remember that I already know dH/dt is -1/10 root h. I'm going to rewrite that as -1/10 h to the 1/2. Okay? So let's take the derivative, because we want to know, is my rate of change increasing or decreasing? That is a second derivative question. So I'll have d squared h dt squared. It's the second derivative. I'm going to take my half, multiply it down. Okay, so if I do -1/10 times 1/2, that's going to be a -1/20. And then I have to take away 2/2 from 1/2. That's going to give me h to the -1/2. But then I have to put a dH/dt on the end. Now, I'm going to rewrite this. If my h is to the -1/2, I'm going to put a root h on the bottom with the 20. So since my exponent came out to be a -1/2, I'm just going to put my root on the bottom, and then dH/dt. Then from there, remember that we have a substitute for dH/dt. We know that dH/dt is really this. So I'm going to go back and I'm going to plug in. I have -1/20 root h on the bottom. And then my dH/dt is -1/10 root h. And so when I plug in my value here, it says when the height of the water is 3, I'm going to find d squared h dt squared when h is 3. It'd be -1/20 root 3, -1/10 root 3. Okay, and now think about, if I have a negative here and I have a negative here, okay, those negatives are going to cancel out with each other. That's going to mean that overall the value is going to come out to be positive. So for that particular value, my d squared h dt squared came out to be positive because these negatives would cross out with each other. So even without thinking about the rest of the number, I know that the rate of height of the water is increasing at h equals 3 because dh squared dt at h equals 3 is greater than 0. Okay, and maybe I should have said the rate of change of the height of the water is increasing. Okay, but because that second derivative came out to be positive, that's how we know. Okay, go down to the very last part, part C. Says at time 0, okay, so coming back to right here, at time 0 the height of the water is 5. So they just told me that the height of the water at 0 equals 5. That's going to be my initial condition that I'm going to use. Use separation of variables to find an expression for h. If I have dh dt and I want h, I'm taking an antiderivative. They even gave you a hint as well that you had to separate your variables. So hopefully you've remembered to do that. So the first thing that you would do is your square root h would have to move to the other side, which means that it's going to have to end up down here on the bottom. So I'd have 1 over root h dh negative a tenth dt. So I'm moving the h over, but I'm leaving the tenth where it's at. Okay, then I'm going to do one more rewrite step, and I'm going to write that as h to the negative a half. Okay, think about why I'm doing that. I'm going to have to integrate on both sides. So when I add 1 to negative a half, I'm going to have h to the positive a half. But then if I have to divide by a half, that's going to put a 2 in the front. So I add 1 to get a half, then I divide by a half and I get a 2. Okay, then on the other side I have negative a tenth t, because think about the integral of a constant is just the constant times x, but in this case we're using the letter t instead, and then plus c. From here I'm going to multiply by a half on both sides to get rid of this 2 in the front. So my 2 is going to be gone, and h to the 1/2 is really just a square root h. Half times a tenth is now negative a 20th t plus c. Notice I already didn't know what c was, so when I times it by a half, nobody really cares. Okay, then from there I'm going to square and square. So I have h equals negative 1 over 20t plus c squared. Then remember that from here they already told me at the top that h of 0 is 5. And if h of 0 is 5, then that means that 5 equals negative 1 over 20 times 0 plus c. Well, then think about that means this is really just 0 plus c. So if 5 equals c squared, then c equals root 5. And then from there I would say, okay, well then h equals negative 1 over 20 t plus root 5 quantity squared. And that would have been your solution. Okay, good job.